What is going on, everybody, and welcome to part 7 of the AI in StarCraft II with Python series. In this video, in the coming videos, we're going to be getting into what I know everybody has been waiting for, and that is deep learning. So, up to this point, we've got just a simple rule-based AI, even though it's just if statements. Some people seemed confused. It is still AI. But what we're going to be doing now is implementing deep learning. Now, right out of the gate, I just want to say, first of all, this is a completely unsolved problem. No one has solved, StarCraft II, and by solved, I mean, defeated expert players, let's say. No one has done that. They have done it in more simplified games, like, if we can remove a lot of complexity from the game, we can definitely defeat human players already. But so far, the actual game itself, and in its entirety, allowing, let's say, us to build all kinds of different units, build different buildings, research different upgrades and stuff like that, that has not been defeated because it's just so complicated. So first of all, let's get that out of the way. Second of all, I do not know the answer to this problem. All this is going to be at this point forward is my attempt at solving StarCraft II with deep learning. All right, so how are we going to do it? So the first thing is, especially with an unsolved task like this, is there is no tutorial that says, oh, use this network or whatever. We have to figure out how we're going to solve it. So right out of the gate, when I have a problem like this, the first thing we got to think about is what do we hope to achieve, but then how can we do it? So we know we want to use deep learning, but first we need to just like dramatically simplify what's going on here. And at least for me, I think the weakest point in our bots at the moment, and a relatively easy task, would be the attack method here. So I can simplify the attack to be, don't attack, defend our base, attack the enemy base or attack enemy buildings, attack enemy units. So I can break that down into 4 really simple choices, right? And then we could take those choices and we could either apply them unit, by unit, or by entire army, or entire idle army. So entire army that's not already performing some objective. So I think the best starting point would be to apply it to the entire idle army. Then maybe later apply it on a per unit basis. I think that would result in really cool things, but I think it will overly complicate things to start. Okay, so we got that out of the way. We know what we want the output of our neural network to be. Now, what's the input? What's the structure of our neural network? Well, I know a lot of people are going to be like, oh, I want reinforcement learning, and the only reinforcement learning everyone seems to know about is Q-learning. I'm not going to do Q-learning here. I think Q-learning is going to be way too complicated for this kind of a challenge, where you take a path, and then if you got the reward, you divvy up that reward amongst all the steps you took along the way in your path. First of all, it's going to result in a huge amount of training data, but not really meaningful. It's just going to be super noisy. But also, it's not really the best solution, I don't think, here. So other than being clickbaity, I don't think Q-learning is actually how we're going to solve this. Again, I don't have the answers, just don't think it's going to be that. There are other forms of reinforcement learning, surprise. But I think what I want to go with is more like an evolutionary learning method. I think that's most fitting here, too. So the idea is to have an AI that makes choices, and if it makes good choices and it wins the war, well, congratulations, you get to move on. You become a continued asset to the gene pool, and if you lose the battle, well, you're forgotten to history. You don't get to reproduce into the future. So I think that makes a little more sense here, and especially if we are able to get down to a unit by unit or something like that, that could be kind of cool. But really, the victorious algorithm either wins or loses as a whole. So anyways, that's the way I want to do it. Okay, so that's kind of the structure of how I want to do things, we still have to talk about, okay, what is the neural network that we're going to use? Because basically, what kind of input do we want to, because basically when you choose a neural network, you got to think about what kind of input we're going to put in. So again, we're going from the end forward here, starting with, what did we want our neural network to output? What are we going to, what are our hopes for it in terms of how it's going to actually learn and, basically learn. Now, what are we going to put into this neural network? And that's going to basically force our hand with what kind of neural network we're going to use. And the issue here with StarCraft II is there's so many variables that are, there's almost a variable number. There is a variable number of variables. And even our variables have variables. So, each unit is a variable, but then the type of unit and where is that unit, all those things come into play. That's just very complex. It's very hard to feed it into a neural network. So immediately we're looking at some pretty complex networks. So to me, I think the simplest network that you can pass any amount of data and any variable data to would be a convolutional neural network, because you could visualize everything. So first of all, you can visualize the unit. You can color code units based on what they are. You can size them. You can also visualize things like our materials, like how much minerals do we have and the gas that we have. You could visualize that with a bar or something like that. And the ConvNet should be able to figure that out. So that's my plan going in. And the first thing that we have to do is basically, well, there's two things. We have to kind of modify this a little bit. We want to further simplify, because you just got to make things as simple as possible to start. If you're successful, make it a little more complex. So the first thing I want to do is I don't want the stalkers anymore. We're going to go with void arrays. Later on, we're probably going to need stalkers, because if we only do void arrays, we really can't defend ourselves against early rushes. So just keep that in mind. Otherwise, I think I'm going to leave the attack method the same, because we're not going to build stalkers anymore. We only need one gateway, and we only need that gateway to build the cybernetics core, which we need for the Stargate. So, rather than this logic, I'm just going to get rid of this and make that 1. So if we have less than one gateway, well, let's build one. Otherwise, who cares? And then we don't want to do a half. We'd like to just build, well, let's just get rid of the divided by 2, and then these extra parentheses here. All right. So, let's see. And then build defensive force. We only want to build the void rays. Okay, so that's the simplified logic. So now for our attack, we only have one type of unit, and all that. We can make that more complex. I don't see any reason when we use the ConvNet that we can't color code and size the stalkers a little different. I don't see any problem with that. It's just right now I want to keep things as simple as possible. If I find this to be successful, we can try to add other variables and see if that, is acceptable, or nope, that throws the whole thing off and it can't figure it out or whatever. So the first thing we always want to do in a case like this is just let's make this as easy as possible to learn for a neural network. So now that we've got that, the next thing that we need to do is, 1, modify the attack method to attack based on some sort of rules. To start, they're just going to be random, and then we're going to let random, just run a ton of games. And anytime random wins, well, we're going to take the set of actions that random took, and we're going to say, hey, these were good actions, good job, Army, and we're going to use that as training data. Any of the armies that lose randomly, we're going to use that, won't be training data. Now, if what we're going to do is against the easy bot, you could just win randomly for no good reason. Against the hard bot, I'm pretty confident if you do things smart or somewhat intelligently, you'll win. And if you don't, you'll lose. So my guess is this will result in good training data. Again, I don't know. I have no idea. So come along. Okay, so we're gonna need to modify that. But first, let's do the input. So what is the imagery that we're gonna see? So to begin, we're gonna use OpenCV just for visualization's sake. You really don't actually, well, Yeah, you should have yeah, you're going to need it because we're going to use OpenCV's drawing methods and stuff like that. So we're going to import CV2 and import NumPy. If you don't have these, NumPy should be relatively simple to install. It's very much like all your other packages. CV2 is not if you're on Windows. If you are on Windows, head on over to Python Permanent Net and do a search for OpenCV. Okay. And hopefully you'll find in that first tutorial how to install it on Windows and all as well as like Linux and stuff like that. It's a little easier on Linux. Windows, you just need to go to that unofficial sources. Okay, so once we have that, we're going to create a new method, and I'm going to call this new method Intel. So the Intel method, I'll just define it or make it right here. Async, let me zoom in a bit. Define Intel self. So Intel will just be the visualization of what's going on in the game. So right now I am gonna handwrite out at least the basic drawing of a thing, and then when we start to build on this, I'm gonna do the copy pasta because it won't be anything new. So the first thing is to draw. We're just going to draw basically the game map. We have access to game information, and so if you did like self.gameinfo, and then game info has .map size. Now, how do I figure out all these things, right? There is a wiki for PySC2, but it's not really the best wiki I've ever seen, and that's okay. No insult. I really like PySC2. Thank you for making it because. I'm sorry, Python-SC2, because PySC2 was just impossible to understand. So anyways, getting back to what I was saying, how do I figure this stuff out? Honestly, you can immediately, you could go to the source code. The other thing you can do, because a lot of times in the source code, things inherit from other things and blah, 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 and it gets really hard to follow. You can always just print dir self and just hope they make useful names, and you can see what are all the methods and just kind of read through them, or you can go to the source code and compile the list by reading it or whatever. Just know that that's honestly what I do. I just go through there and see what my options are, and that's how I found game size. I just figured it would be in there. So what we're going to say is game data, and this will be the initial image, and we're just going to make that np.zeros, and then in np.zeros you pass a shape. So in the shape of our np.zeros, it's going to be, so the shape will be a tuple basically, that will be self.gameinfo.map size, and then 1 firsteth, and then the 0th. Oh my gosh, what is Harrison up to? What is he up to? So in an array, it's height by width, but in the image, it's width by height. So we're going to reverse these because we're using an array for an image and we kind of want to flip them. Okay, next thing is it is not just X and Y, they also have color. That took an embarrassingly long time for me to figure out what the heck was going wrong. And then this will be our data type. So, okay, so that's game data. Now, let's say we want to draw stuff. So let's say for Nexus in self.units of Nexus type, we want to draw them. So we're going to say the Nexus, let's say next position is nexus.pose. Actually, it'll be position. Again, how did I figure that one out? I printed out the dir of it. That's it. So, and then I just read them and I was like, okay, position sounds like what I want. And sure enough, it was. So that's next pose. So then we're just going to draw this to our game data. So cv2.circle. And then in circle, you say, where are we going to draw this circle? We're drawing it in game data. And then where on this game data are we going to draw this circle? Well, we have to draw to ints in cv2, if I recall correctly. So int, and that'll be next pose 0, and then we'll do int next pose 1, and then is that correct? Let me hold on. Too many parentheses here. Okay, so finally What is the size? We're going to make it 10 pixels. It should be pretty large. It's your nexus. It's important. And then what color? This is BGR. So 0, 255, 0. That's 0 red. I'm sorry, that's 0 blue. Full green, 0 red. BGR, Harrison. Okay. And then I think the next value is line width. I'm just going to say -1, and I believe that just makes no line width. Okay. So that draws everything. Fancy that. Then what we want to do is, again, so an array is height by width. We already kind of flip that around for ourselves. Now the last thing that we need to do is, so OpenCV is going to work with 0, 0 as like the top left, but coordinates are going to work with 0, 0 as the bottom left. Thus, we need to flip things. So we're going to do flipped equals cv2.flip. We're going to flip that game data on the 0th axis. And then we're basically done, but I'm going to go ahead and resize it. Depending on your screen resolution, you might not need to do this. It's just I couldn't, it was like so small on my screen. I just wanted it a little bigger. I can't see things. So resize, cv2.resize. The actual imagery that we're going to save and use our neural network on, though, is going to be the flipped image. You wouldn't want to pass resize. It would just be a waste of data, really. So anyway, flipped, desize, none, fx, 2, and then fy is 2. So it's like the function of x and the function of y. It's just we're just multiplying by 2. Then we're going to go cv2.imShow, and we're going to show it as Intel. What are we going to show? Resize. When are we going to show it? Now. Just kidding. Wait key. 1 millisecond, and that's it. And we should see some data. Let's run it, and hopefully we didn't hit an error. We will see. And hopefully we get a pop-up of the CV2 window and the placement of our nexus. Shoot, let's see. Nope, that ain't it. Where? Dude, is it not going to show up for me? Oh, we never called Intel. Okay, yeah. Awesome. So... okay, await self.intel. Okay. All right. While we wait, thank you to my recent sponsors / members. They're going to change the name at some point. Igor, Eduardo, GG64DUO2, Huyu, Najib, Siva, Fuba, Jun Wang, and Sam King. Thank you guys very much. You are all awesome. Oh, we hit error. NP is not defined. Oh, we didn't import NumPy as NP. Okay. We'll try again. Wow. Oh, how did that get there? Oh my goodness. Whoa, look at that button. Beautiful. Okay, hopefully this works now. Please don't crash. Oh, that doesn't look like I wanted. Okay, this will be one of our last errors. I guarantee it. So camel case wait key, because it's Python and that's how they like to do things. Come on, this better work. The people are gonna start riding. Got it. Okay, so this is basically the map, right? And then this green dot is our nexus placement on the map, and then boom, we just set up another nexus. It looks a little down for some reason. I think this is just all empty space. It might be like trimmed or something in this map too. It looks like things are oriented correctly. We'll see if we get a third nexus. And just in case I forget to mention it, one of the things that we definitely want to do is if we send up another one, I'll show it. we're showing the Nexus on the map before it's actually built, before it's actually ready. You'd probably want to only show it when it's ready. Wow, this guy rushed. Whew. He's going to beat us, I'm pretty sure. Oh, we did actually get some Void Rays immediately. See ya, buddy. Get out of here. You joker. All right, so, oh, there's the other Nexus. So it's building, but we're already showing it's up. That's probably a mistake. You probably don't want to do that. You don't want to do it ready. Anyway, we're going to do the rest of this stuff in another video because this one's probably getting super, super long. If you have any questions, comments, concerns, whatever, feel free to leave them below. Otherwise, in the next tutorial, we're going to continue drawing beautiful pictures onto our screen here for visualizations. Then we'll save the data and hopefully train a model that is better than random. All right. Till next time.